Hi guys, good morning. So today we are going to solve Leetcode daily. It's question number 3116, the kth smallest amount with single denomination combination. Okay, we are given an integer array coins representing coins of different domination and an integer k. You have an infinite number of coins of each domination. However, you are not allowed to combine coins of different domination. Return the k smallest amount that can be made using these coins. So coin 369 is equal. The coin can make the following amounts. Coin 3 produce 3, 6, 9, 12, 50. Coin 9, 6 produce 6, 12, 8, 24, 20. All of the coins combined produce 3, 6, 9, 12. Your infinite number of coins of each domination, however, you are not allowed to combine coins of different dominations. Okay, what does this question mean basically? Coins 5, 12. Actually, I'm not getting the question. Like what it means. So you are given an integer array coins representing coin of different domination and an integer k. You have an infinite number of coins of each domination. However, you are not allowed to coins of different denominations. Then k is smallest amount that can be made using this coin. K is equals to 3. Okay. Guys. For k is equal to 3, we have written 9s. For k is equal to 7, we have to return like this. How much k value can go? Bloody hell. Are we going to use binary search in this? The coin length must be 15 only. And the coins are 1 from 1 to 25. Should we pre-compute all the values for 1 to 25? It's always Leetcode hard. Coins contain pairwise distinct integers. So like at max you can go from 1 to 25 in worst case, and they will give you a value of 10 to power 4. Then if you personally ask me what we have to do this question, we have to combine two arrays, then sort it, then return. So for example, for this for int I is equals to y, I is equals to 1, I answer dot int num is equals to coins of I. Okay. For int j is equals to y, j less than equals to j, int val is equals to num multiply by j, answer push back by stored answer dot get. return. Okay. So this is basically what we have to do. Like to pass the test cases, this will going what the fuck. Oh, yeah. This is what we have to do. And it's already 227 ms, so it will going us to give a TLE by anyhow. But let's see how many test cases are there. Bro, it's give me wrong. Ah, 5735. What the hell, bro? 5 Oh, okay. Firstly, sort the array, then I will say auto IT equals to name. It's going to be k minus 1. Yeah, brother. Now I'm thinking like previously also I'm thinking right only. Due to some misconceptions, I have to write k because I'm not removing the unique items. Their answer must be unique, guys. That must be unique. It will give me a TLE now, for sure, right? So here comes the biggest part: how to avoid this solution without submit the solution without TLE. We have to think of it. Well, I think for this, oh wait, where the fuck that? You know what? This solution will pass by this also. Previously, I took like 1,000 values. That is way too much, but this will pass. Yeah. So now it will submit around 300 something question. Wow, what the 502, bro? It's great. That's fucking great, brother. Let me put it at long. Then we return an integer. Guys, we return an integer. Use this test case. Bro, k is like way too much now. Yeah. Like how much? 3, 4, 5. Okay. But now it will give me TLE. Like, see, this solution is not optimized at all. It's a brute force. Like, it's a basic solution. Now we have to optimize this. So, what we are going to check, we are going to create an array of 10 to power 9. Like, yeah, we are going to create an array of this size. Then, instead of multiplication, we are going for addition. Uh, Basically, it's a maths problem. It's a maths problem like uh, what can we think of it? If I submit it, then it will only pass 200 test cases. At max 200 or 90. What can we do? What can we do? What can we do, guys? What can we do? What can we do? Uh, so for like 2, 4, 6, 8, 10, 12, right? Now if the other element is 4, then we have to skip 2. Now if other element is 4, if the element is already divisible by some other elements, which is smaller, then we don't have to compete for 4. So, if the element is already divisible by some other element, we have to for it. Let me sort points. Don't begin. Points dot end. Vector individuality. Vector. Ooh, 1 E9 plus 7. Vector points. Okay. Okay. If visited num if visited num is equal to false. Sorry. Is equal to true. Yeah, false. Then only go for it. Isn't it great, guys? Isn't it great? Oh wait, but I read this one. Visited of y equals like 4, 5. 1 or 6. Brother, we have reduced some time, guys. We have reduced some time, so it's a good way of thinking. Hopefully, but it will still give us a TLE. If you know, you know. Brother, this is 24 disk. So for this, we don't have to compute for 4 only, but we have to compute for 5. So, one these ones. 529. Let's see how many disks there. Rows of 386 ms. Now we have to think somewhat further more. What can we do? Because it's a lead code, I think now we don't have to need this. Wait a second. Oh, we have to. Yeah, 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 yeah. Now this is also an issue basically. You can see. I have to put elements in such a way that it will get sorted eventually. Instead of this, I can use a set. Wait. I am CRT. How to return well index insect. Photo IT history.pn advanced IT. Okay. Photo IT return advanced IT. This will work. This will work. Maybe it will work. Circulation. Bro, why are you twisting? Let be an integer, you piece of shit. Ah, okay. I haven't seen this, guys. Advanced IT implementation. It's a pointer. We have to do the pointer. Yay! So we have solved one problem now. We have solved one fucking problem, guys. La la la. Still, we need to optimize this code, but we have solved one problem. 19 decimal sequence. And max 39. So we have to think for something more. Set is good. This one is good. The array is being sorted. I think if I don't sort the array, yeah, it's necessary to sort with the array. That's good. Then we will do set also. Oh brother. Oh, in 2014 I tried this question, guys. And what did I do in the first time? What the fuck I did? I use a hash map and I use priority queue. What the fuck? Is this question going to solve a priority queue? That's what I'm saying, guys. It's going to solve a binary search. Fuck binary search. This question is going to solve a binary search, guys. Binary search. I must have used the question. Bro, what the fuck? We have to do the bitwise masking here. Seriously, a hard question, huh? Like, especially, it's a good question actually. Let's check the tutorial binary search plus inclusion and fusion principle. Wait, guys, let me get an understanding of the question, then we will continue to solve this. So, hi guys, so we are continuing our lead code hard question now. So, like, what the main purpose what I think previously, yeah, that side we are going to use binary search with bitmask. So here's what ChatGPT explained to me, and let me explain to you also. So what happens, like, see, for some cases, like assume we have a 369 for our first test case, right? We go to 3 6 9 15 and everything, and for 6 like 6 12 18 5 like for 9 9 18, right? So the thing is, we can't do till k, we can't calculate till k. So what we are going to do is we are going to find a particular occurrence and check whether in that range are already k elements, like k occurrences multiply or divide multiplied by the nums is present or not. So for that, what they did, like, instead of finding kth directly, what we are going to do, we are going to use for binary search, right? So could mid possibly the k smallest number, because we have to return the k smallest number. So if for some find out if we are at a mid and we check, like, yeah, the k smallest number is already present, is beyond k smaller number, then we can move our high to something like a position. Let me record and let me explain it to you. So let us assume our int is equal low is equal to 1 and int high is equals to 1e11. Okay. So while low is less than equals to high, and our mid is, as you know, in binary search, mid is equal to low plus high minus low by 2. Now if now we are going to use a function, like we are going to check the occurrences, like int occurrences, like how many elements. We are making a helper function, making a solve function for it. We're giving a mid and we are giving coins. Now see, the thing is, we we are using a range, okay, and in the range we are providing that in the particular from start to mid is the number of occurrences, like, is the number of occurrences is less than k. It means we haven't reached our k smallest element. Then what we are going to do, we are going to move towards the right part of the array, like right part of 1 to like a 1 111. So we will say low is equals to mid plus 1 easily. Else, if there is already k occurrences or more than k occurrences present, firstly we check answer is equals to mid, and then we say high is equals to mid minus 1, and at the end we are going to return our answer. So long answer. One thing is that, let me put everything long so don't have to confuse whether while we're going to submit the answer. Okay, now we are going to do, like, we are how we are going to check the occurrences, like how we are going to check the occurrences, whether these occurrences which are divisible or by the particular coins area present there or not. So let's say long solve long mid and vector and coins. Now come the second part of the question, guys. Now we are going to use the solve function, right? So the solve function currently takes the coins array and the mid value. So this function serves how many numbers from 1 to mid are divisible by at least one coin. Like from 1 to the middle element, how many number are divisibles, right? So because number of divisible items give us the count, like how many the care divisible item are present there or not. Okay, so we will say like count coins are 3 and 5, the mint is 1 to 20, so we have to see from 1 to 20, so number of element divisible by 3 or 5, counting multiples of one coin. So how many numbers less than is equals to 3 are 3, 6, 9, 12, 15, 18. Which means if the number is mid is 20 and I have to count how many elements are divisible by 3, then that is 20 by 3. So it's a like 6 elements. 20 by 6 is 20 by 3 is 6 is 18. Yeah, 6 elements. So that's why 3, 6, 9, 12, 5, 18. So those are 20 by 3, 6. Now how many divisible by 5? Then 4. 20 by 5 is 4. So 4 elements. So we might think the answer going to be 6 plus 4, 20. But no. Because the 15th element comes in both sides, so what are we are going to use? We are going to use the inclusion and inclusion principle. What the inclusion and inclusion principle states that the formula is if count of A or B is equals to count of A plus count of B, and we have to subtract the common count. We have to subtract the count of A and B. For our example, divisible by 3 are 6, divisible by 5 are 4, and both divisible are 1. So we are going to see the number divisible by 3 and 5 are divisible by uh, LCM of 3 and 5. Okay, so therefore 6 plus 4. Why LCM? Because suppose we want number divisible by 3 and 5, they need to be divisible by both. Those numbers are 15, 13, and that's why. So therefore mid divided by LCM of 3 and 5. But what if we have many coins like 2, 3, 5? We need divisible by 2, 3, or 5. So multiples of 2, multiples of 3, multiples of 5, minus multiples of 2, 3, multiples of 2, 5, multiples of 3, 5, and then at the end plus of 2, 3, 5. This is exactly what the bit masking is doing. Understanding a bit mask. Now we are see what the bit mask concept is doing. So in bit mask, one m if m is equals to 3, now we have converted m to binary. Sorry, we are masking 1 here. So the thing is, guys, we are not masking m here, we are masking 1 here. So for 1, when we do a left shift operator for 3, so from 1 0 0 0, when we do 3 times, it will go, first will go 1 0, then it will go 1 0 0, then it will go 1 0 0 0, and then we subtract 1 0 0 is 8. Now when we are going to subtract minus 1, that is 7. So mask is 7. So for int, we go from 1 till mask. What is how to get the m? Wait, let me check how to get the m. Oh, m is the coin size, guys. M is the coin size. So we're going till the array, like the size of the array. Okay. Now for coins 2, 3, 5, bit of 0 is coin 2, bit of 1 is coin 3, and bit of 2 is coin 5. Okay, okay. Now like we are counting the array elements. We made a mask based on the array elements. So for zeroth index the bit is 0. So for first index the bit is 1, and the second bit is this. So 1 binary is 1 2 3 selected coins are 2 and 3. For 4 is 5. This is the reason for it has is coin J included in a subset. Okay, let's understand this line. LCM is equal to LCM comma coins of J. Suppose our subset is 2 3 5. Now LCM is 1. After coin 2, the LCM is again 1 comma 2. After coin 3, the LCM is 265. So 13. That means number divisible by 2, 3, 5, and 6 are exactly multiples of 13. Therefore, made is count. The clever part is now we need to know whether we should add or subtract the subset. How many bits are set in I? If I is equal to 5, 2 bit set. Pop count 2 bit set means the zeroth and the second is being included. Okay, now we somewhat understand what we are doing, but let's code it. So int m is equal to coins dot size. So we are making a bit set, bit mask of size m. Okay, the question is hard for a reason because firstly it is using binary search on answers, and next thing is let me create a mask of 1 minus 1. Now for int I is equals to 1, I less than is equals to mask I plus plus. Now we're taking LCM as 1 firstly. Now for int j is equals to 0, j less than mj plus plus. If I and 1 left shift j, LCM is equal to LCM of LCM comma coins of j when we are out of the for loop. So if built in pop count I, then we do an end with 1, then we say count plus is equal to mid for LCM else count minus equal to mid divided by LCM return count. I somewhat understand it, this question, but not didn't fully get the question what question means actually. So again it's what the hell we did wrong. Sorry. I think this is not the issue. That's simple binary, it's not a issue. Okay, low plus. You know what biases we do low plus high minus low minus high minus low sometimes. Yeah, I think we are submitted, but I am not fully satisfied with my solution today. I will try to read this question again one more time and like try to understand again like what the question actually means. I know this is going to be used binary search, so at the start of the video I already told let's assume it's a binary search. But yeah, now they are doing the bit count and bit masking. I know what bit masking. You have studied about bit masking, so you can also watch the video by Love. He's a CP guy, so he uploaded video what bit masking really means. But yeah, I didn't fully grasp the concept, so I have to do it again. Okay, guys. Thank you. Bye bye.